Hello, my name is Diego Assis and I will be presenting to you our work titled An Experiment to Access an Acquisition Platform and Biomedical Signal Conditioning. So, in this presentation, I will talk about the purpose of the work, the experimental goal, the platform name you make, the experiment planning, the experiment steps, the results, and future work. The purpose of this work is to develop a low-cost framework for acquisition and conditioning of biometric signals and to evaluate it through the system usability scale developed by John Brook. The experimental goal of this work is to show that UMake can be used as a low-cost tool for the acquisition and conditioning of biometric signals in the teaching-learning process in the biometric field. UMake is a framework for acquisition and conditioning of biometric signals formed by a set of interconnectable, interconfigurable, and reconfigurable bots. It has strong documentation with a user guide explaining the step-by-step how to use it and an explanatory video on YouTube. In addition, it has a low cost, since UMake allows the user to use both the LM324 integrated circuits and the AD620 for signal acquisition. Thus, in the experiment of this work, the LM324 was used for having the lowest price. Here, we will show you make models. The first model counts on the input of the electrodes and the amplifier of the signal, something around 7 times. The second model has a common mode rejection circuit. The third model is a high-pass filter that may be suitable according to the desired signal. The fourth model is amplification mode, in which the signal is amplified several times according to the requirements of the desired signal. The fifth model has a low-pass filter that must also be adjusted according to the desired signal. Finally, there is a 60 Hz band-stop filter. So, in experiment planning, we have an objective definition. The goal was formalized using the GKM model proposed by Basile. Analyze the biometric signals platform in order to evaluate, with respect to the usability and time prototyping, in the point of view of students and former students of undergraduate and postgraduate with and without experience in the study area, in the context of the people interested in the study area. Here we have hypothesis formulation. Research question 1. The group with the most knowledge and experience in the area has an average value of usability higher than the group with less experience and knowledge. Research question 2. The platform can be used as a low-cost alternative for the acquisition and conditioning of biometric signals. Research question 3. The group with the most knowledge and experience in the area has the lowest average value of prototyping time than the group with less experience and knowledge. Here we have metrics and hypotheses. Metrics: average usability of each group, overall average value of usability of the experiment, average time prototyping of each group. Choose new hypothesis. The average usability value of the experienced group is equal to the average usability value of the non-experienced group. Choose alternative hypothesis. The average usability value of the with experience group is higher than the average usability value of the no experience group. Time new hypothesis. The average prototype time of the experienced group is equal to the average prototype time of the no experienced group. Time alternative hypothesis. The average prototype time of the experienced group is higher than the average prototype time of the no experienced group. The ICEIS scale was used to assess the usability of the platform. The ICEIS scale is a Likert scale of 10 statements, where the user answers the statement by marking a response that goes from the strongly disagreeing to strongly agreeing with the statement. In this experiment, the dependent variables are the metrics, the independent variables is the platform itself, and the intervening variable is the participants' emotional state. For the experiment, 24 participants were selected, 12 with experience and 12 with no experience. The pilot study was done with an electrical engineering professor, and after that the participants performed the experiment by acquiring ECG, EMG, and EOG. Now we have experiment steps. In the preparation of the experiment, participants were given an explanatory video and a user's guide. At the execution, the participants set up the experiment and completed the SEALS scale. To validate the experiment, we used the Shapiro-Wilk statistical tests to test normality, Levene to evaluate the homogeneity of the variances, and finally the t-test to compare the average of two independent samples. So, let's go to the results. To answer the research question 1, the statistical tests results showed that there isn't enough significance for the means of the groups to be different. Thus, there is no evidence to reject such null hypothesis. To answer the research question 2, you may obtain the general average usability grade A+, according to the usability scale defined by Searle and Lewis. To answer the research question 3, there isn't enough significance for the prototype time of the groups to be different. Thus, there is no evidence to reject time null hypothesis. The future work is integration of the UMake platform with the Prod digitalization platform. Question? Send me an email. References? Thanks.